Good afternoon, everyone. My name is Vibhu'S, and my experiment is about biofuel. Last year, I got interested in the G20 summit. The G20 aims to address major issues related to the global economy. Last year's main agenda was sustainable development and climate change. In sustainable development, they talked about implementing biofuel as an alternative to fossil fuels such as diesel and gasoline. Which is why, for this experiment, I wanted to make biofuel and test it. But what is biofuel? Well, biofuel is a renewable fuel that is made from plants and animals, which is called biomass. This is animal fat, which is a similar source which I used in my experiment. What are the benefits of biofuel? Well, it has more energy. It's more energy effective than fossil fuels like gasoline. It also reduces foreign oil dependency. Did you know that Japan imports 2.5 million oil barrels per day? Just imagine Japan produces more biofuel. That could itself help reduce the foreign oil dependency and in turn has a positive economic impact by increasing the GDP of a country. It's also a sustainable resource because fossil fuels are a finite resource, which means they cannot be produced for a very long time. Biofuel can be produced because we always have plants. Look at the history of biofuel. Biofuel production started all the way back in 1930 and was used in the World War. But after the World War ended, we forgot about it, and we started using it back in 1995. In 2009, there were 200 million manufacturers worldwide, and in 2030, we predict that biofuel demand will increase by 6% for use in transportation. Which brings us to my experiment. The aim of this experiment is to create biofuel and conduct some tests on it. The question is biofuel an eligible fuel source? My hypothesis is it is an eligible fuel source because during my research, I saw people using biofuel to power their cars. My method is to use the trans-esterification process to create biofuel, which means using plant and animal waste to create biofuel. I will use the calorimetry to test the energy quality of the biofuel. This is my experiment process. This may not make sense right now, but in the coming slides, you will understand it a little bit better. First is making the plates. For making the plates, I will add 20 milliliters of water, some brown silicone powder, and the plaster of Paris. Then I'll stir it and quickly coat it, and then bake the plates at 220 degrees Celsius. This is how my results should look like, but my first test was not a success. As you see, the coating broke off the plate, and it was also very brittle. I think it broke off the plate because the silica gel was too thick and absorbed all the water. It's also because I didn't break the plates. My result, too, was also not a success. As you see, I tested this plate with oil, but the oil is not visible. The oil is not visible again because it was too thick. But my result 3 was a success, and this video shows how I created my plates. First, I grinded it and then mixed plaster of Paris, silica gel, and next I cooked the plates. This is how my plate looked. And then after I baked it, this is how the result of my plate. Next, we go to making biofuel. For making the biofuel, my prime ingredient is lipase. I'm going to create 2 types of biofuel, without buffer and with buffer. They're both the same, except the with buffer has buffer added into it. For this process, I've included lipase, which dissolved in the oil and methanol. Then the solution was incubated in 40 degrees Celsius for 24 hours. After 24 hours, I took it out and then centrifuged it for 10 minutes. And then I extracted the top layer from the liquid. The reason I extracted the top layer from the liquid was that the top layer was the biofuel. Next, we go to TLC. TLC stands for thin layer chromatography and is used to check if an ingredient has esters in it. My prime ingredient for the TLC is acetone and sulfuric acid. Step 1 is the moving of the liquids. As you see, a tiny amount of biofuel and oil is placed on the bottom edge of the liquid. And then, after I place both of them down, I will submerge it into that glass beaker over there, which contains acetone. Acetone moves the liquids up, which makes it easier for me to see if it is actually biofuel. After that, the acetone evaporates from the plate, and then I spray the plate with sulfuric acid. After I spray the plate with sulfuric acid, I char using a heat gun. And while I'm doing charring, you can see that there are some black spots appearing on the plate. That signifies that it could be biofuel or oil. Well, I use oil as a control, so that first spot over there is oil. After I finished the TLC for both my plates, I compared it. The blue highlighted spots are the oil. the dark spots, and the two red spots, or the biofuels. As you see, no buffer is very light, which contains less or even no esters, which means it's not like the biofuel. But yes buffer biofuel is darker, which means more esters, which means possibly biofuel. Now comes calorimetry, which is used to test the energy quality of a substance. For calorimetry, you can see that there is a bowl which has aluminum on top of it. And then we have different substances like methanol buffer, and yes buffer, no buffer, and methanol, no buffer. Methanol is used as a control. After I light the substance, the heat from that substance goes to the water, and the water has a live thermometer measuring the substance heat. After I measure all the substances, I take those substances and heat it into Q equals M times C times T. Q is the heat absorbed by water and is the whole result of my experiment. After that, I keep it into these results, which is joules by milliliter. But these results will be turned into a bar graph format as you see over here. You can see that buffer methanol has the lowest energy so far, and no buffer methanol have the highest, which is 6.9 voltjoules. Which brings me to my conclusion. The conclusion shows that biofuel, I have actually created biofuel, since yes buffer in the TLC test had the best result. But in the calorimetry test, the buffer had more energy than the yes buffer. Believe it or not, this experiment took 5 months from planning to completing, but here it is in a 10-minute presentation. I would like to say thank you to Mr. Fred, the research mentor, for supporting me through my experiment and research. I also like to thank Laura's school for having one of the best science labs. As you know, this is actually a university research topic, and that means that this has literally no end to it. My next step is to find out ways that biofuel can be utilized with its maximum energy. Without further ado,